Good morning, grade 12s. So today we're on lesson 9. Now we're going to start problem solving in 3 dimensions. Okay, so let's just go through the first example so that maybe we can understand better what 3 dimensions is really all about. Okay, so here's an example. R and S are 2 points in the same horizontal plane as Q. Okay, so that means R and S and Q are in a horizontal plane, which means they are flat on the surface. Okay, as the foot of a tall building, right? So the distance, so the tall building, we can already see that it's PQ here, right? So that they're at the foot of this building here. So this is flat ground, this is the building at the top, right? So that's why we call it 3 dimensions. Okay, so the distance between S and R is 720 meters. Okay, here it is. The angle of elevation of P from point R is 18.4 degrees, right? So we just need to understand which one is the 18.4. Okay, so the angle of elevation is 18.4 degrees, so that means this is the angle of elevation. It's this one here, right? And addition SRP. Okay, so we're given the angle SRP, and we're given the angle PSR 60,3 degrees here. Okay, now we're supposed to calculate correct to 1 decimal place, so that is important. We need to follow that. The height of the building PQ, this distance here. Okay, now what lengths do I need? Well, I need to know one of these, either the RQ or the PR. I need to know one of those in order to be able to calculate that, but I don't know any of that. Okay, but I can find PR, right, from this triangle here. So we can derive PR from the triangle here, this one. Okay, so we can do that. Okay, so I know 2 angles and 1 side. That means we're going to use the sine rule. Okay, so 720 over that angle, but we don't know that angle, but it's easy because it's the 3rd angle of the triangle, and thus divided by that. So now what we need to do is to find angle SPR first. Okay, so angle SPR is equal to 180 degrees minus 60,3 plus 112,6. Okay, and if we just do that in the calculator, okay, so 180 minus 60.3 plus 112.6, close the bracket. Okay, compare that, and that becomes 7,1 degrees. 1 degrees. Now when we use our sine rule, okay, so by sine rule, remember your sine rule, so it becomes what, 720 or 720 over, okay, so remember we found this angle to be 7,1 degrees, so 720 over the sine of 7,1 is the same as this PR that we don't know over the sine of 60,3 degrees. Okay, now we're just gonna cross multiply by sine 60,3 by sine 60,3. Okay, so what that means is that PR is equal to 720 times sine of 60 3 divided by the sine of 7,1. Okay, like that, right? And now we're just going to take out our calculator and calculate that. So 720 times sine of 60,3 over sine of 7,1. Okay, but remember our instruction is to leave this in one decimal place. So that means this is 5059,9 meters. Okay, so that is the length of PR. So now if I know the length of PR to be 5059,9 and I know this angle to be 18,4, then it's easy to find that using our sine ratio, because we are looking for the opposite when we know the hypotenuse. So to find that, we are now just going to say the sine of 18,4 degrees is equal to the opposite, which is PQ, the one that we're trying to find, over the hypotenuse of 55,9,9. Okay, so what that means is that PQ is going to be equal to 5059,9 times the sine of 18,4. And then if we just take out our calculator, we're then going to say 5059,9 times sine of 18,4, close the bracket. So that is 1597,15. So that rounds off to 2,2 meters. Okay, so that is the height of PQ. Right, what else do they want us to find? They want us to find the area of triangle SRP. Oh, that's the triangle that we had highlighted in this green color. Okay, so that means we're going to have to use our area rule here, right? Remember the area rule, okay, that we said before, where the area is going to be equal to half A B sine of theta. Right, now remember we need to know two sides and the included angle. So we know this 720, we know that's 5059,9, and we know this included angle. So we're just gonna go ahead and substitute those into the calculator. So 1/2 times 720 times 5059,9 times the sine of 112,6. Okay, so let's just calculate that in the calculator. So 1/2 times 720 times 5059,9 times sine of 112,6, close bracket. Okay, so there it is, quite a big number, 1,681,686, 499 is a big number, so that's 5, and these are square meters. Okay, so that is how we work out example number 1. Okay, so on example 2, A, B, and C are 3 points in the same horizontal plane. Okay, so A, B, and C are in the horizontal plane, which means it's these points here, A, B, C, are in the horizontal plane, so everything else is going up, right? such that ABC is an equilateral triangle. So basically what that means is that this is equal to that is equal to that, and this is 60. That whole angle here is 60, and that whole angle here is 60 because it's an equilateral triangle. And then D is a point in the triangle such that DC is equal to BD. Okay, so they've already shown that this is equal. Okay, BC is equal to X meters. All right, DC, okay, so the line DC here and BD here, they bisect triangle ABC and ACB respectively. Okay, ABC, so ABC, so if this is 60, that means this is going to divide that into 230s, and this is going to divide that into 230s, right? And then also ACB, which one is triangle A, which one is angle ACB? Okay, so those are the angles. DE is a vertical pole. Okay, so DE is vertical, which is kept in position by 3 wires. AE, which is this one, CE, which is that one, BE, which is that one. Okay, so the angle of elevation of E, okay, the point E from C is this alpha thingy over here. Alright, so that's this alpha. Okay, now let's calculate the size of angle BDC. Alright, so if this is 30 and that's 30, that gives them 60. Subtract that from 180, and that is 120 degrees. Okay, let's put that in writing. So to get BDC is just going to be 180 minus 30 plus 30. Okay, so let's calculate that. So 180 minus 30 plus 30, close the brackets, so that's 120 degrees. Okay, now here's the interesting part. We have to prove that from D to E is given by that over there. Okay, so what do we need to find that? Okay, let's see, what angles do we know? Okay, so we know the angle of elevation to point E from here is this alpha over there, right? The angle of elevation, so that is alpha. And so and now what we need to find out is this line here, DC. Okay, so now the question is, how are we going to do that? So by sine rule, we know this is 120. So by sine rule, we know that DC over the sine of 30 is equal to BC, which we know to be X, is going to divide by the sine of 120. Okay, so just cross multiply the sine 120 both sides, so that X becomes equal to DC times, okay, sine 120, we kind of know that, isn't it? So let's calculate it. Sine 120, just square root 3 over 2, so times square root 3 over 2. Okay, sine 30, we kind of know that, that's a half. Okay, so that means X is equal to, so square root 3 over 2 divided by a half. Okay, let's just quickly see what's that going to give us. Square root 3 over 2 divided by a half is square root 3. So this just becomes square root 3 times DC. Okay, now we go back into our diagram there. the length that we're trying to find is DE. We found DC to be that. We find alpha to be that. So what do we know about DE? Well, what we know is that if we now take the tan of alpha, okay, that angle there, remember, is the opposite, which is DE, over the adjacent, which is DC. But okay, which is DC. Okay, but we know DC to be what? To be x over square root of 3. Why? Because on the final answer here that we had there, if we divide both sides by square root 3, we find that DC is going to be equal to x over the square root of 3. Okay, so that is what we're going to come and substitute over there as DC. Alright, so now we're just going to cross multiply the x over square root 3, both sides, x over square root 3, so that DE becomes equal to x over square root 3 times tan of alpha. And then that is how we prove that. Okay, so there are some exercises after these examples there in your notes. Please try as many of them as you can, and let me know if you have any problems or if you've managed to do them. And thank you. We'll see you next time.